All right. So the first thing I want you guys to do is put your name at the top. You want to be able to get this back if you lose it for any reason. Okay. Now, this is, I should have told you, but this is height in feet. Go ahead and open your journal. We're going to put this on the title page. We're going to call it Quadratic Regression. I think it's going to go on page 30. Yeah, mine's going to go on page 30. Now, if you're on a different page, it's okay. It's expected prior knowledge, but I will not be checking your journal to see. Okay. So then I'm going to just go ahead and open to page 30. Quadratic regression, just like it says at the top. I'm going to turn on my calculator. I'm going to go to my home screen. I'm going to pause for a second so everybody's there. I see people still writing, so I'm going to pause. I'm going to try to zoom in a little bit. I think it works better zoomed in. Now, it's actually easy to read the calculator when it has the dark background, but as soon as I open the new document, it's going to be hard to see. I'm literally just going to be reading these steps out to you. So, what's our first step, you guys? So we're going to open a new document. So I'm just going to press enter. It's going to ask me if I want to save. We don't. What's step 2? Go ahead and enter that. Step, we're going to change the names of the list to X and Y. How you do this is, you see this guy? You're going to arrow up so that we're at the top. You're just going to type the letter X and press, you can either press enter or tab. I like tab because it's going to get me right to B where I need to be. And I'm going to change B to be Y, and then I just press enter. Don't put anything in the equals space. If you put something there, it's going to mess up the whole thing.
Wait.
Pause, okay, we can pause. Do you mean to back it up? Okay, let's go to the home screen.
No, I got it.
Oh, okay, at the home screen, we're going to Yep. What's step 3? Yep, so you just arrow up and you say X, tab, Y. Okay, what's step 4, you guys? Okay, so we're just going to put all this information in here. 0, 1, 2, 3. So this is my X coordinate, this is my Y coordinate. Good job. My tea is cold. It's okay. Anybody allergies killing them? I'm like, if I could burn the cedar down, I think I would. That's crazy. You guys got this? Okay, the next part, I didn't know how to type it on here, but all you have to do is, you see where your cursor is highlighting the squares? If it's highlighting any of the squares that have data in it, it'll mess up the next step. So just make sure you're on a blank square. Doesn't matter what blank square, but just make sure you're on a blank square. Then you're going to press menu 416, and if you want the vocabulary, now the reason we renamed the list is so that you could just see with those little funky brackets. They're kind of annoying to find, but you can just tell it that it's the X list and the Y list. So here you're going to put X and Y, and then if you grab the highlighter, all of this stuff, you're not going to change. So even though that's in the list and it's telling you to fill it out, just leave it alone.
So what do we do after we write all the numbers out?
Menu 416, and then you're going to get here. Then you're going to put X in for X, Y in for Y. So far, so good. Now you just press enter a few times. I usually do it twice. It's going to pop up all that information for you. So it just did the math to figure out, let me get a scratch paper. So this is like, at 0 we were at 4 feet high. At 1 we were at 9, then we were at 12, then we were at 9 again. This just did the math to get it as close to those dots as it could, so that the distance from the dot to the curve was as small as possible. It does the math magically for you, and this number down here, this is called r squared. You can kind of think of it like how close, like a percentage, like how close is that to 100%, right? 97% is pretty close. That's how good it is at estimating the curve based on those points. Does that make sense? Okay, so in real life, are you ever going to be able to get exact data perfect?
Yes.
Usually not. So this is doing all that math for us. So now we're going to write down the important information that it's giving us. On your paper right here, just draw a line. We're going to write the important information down here, up here, and we're going to explain what it means down here. Okay, so if I put my cursor, or if I select that, so at the top right here, I'm going to write down AX plus BX plus C. What did we find A equals? Okay, you're going to get long decimals. You only place it, okay? What did we get for C? Good. Now we're going to put it into the equation and show what it means, okay? Now I'm going to say the height at time t. So however high the h stands for height. The t stands for time, okay? The height at time t would be -2 independent variable because it's time plus 3. You guys following me?
No.
Okay, what would you like me to do? Which part would you like me to explain more?
What is the
h of t. If it helps, you could think of it as f of x equals negative 2x squared plus 7.8 x plus 3.8. They're the same equation. This is just telling you that it's going to give you a height based off of the time. Does that make sense? Yeah. Okay. Now this format, one of the things you have to be able to determine in Algebra 2 is the difference between vertex form, which if you remember the basketball thing we did where you had to make the curve that goes in the hoop. So that curve on the very last question, it gave you something like f of x is equal to, I don't remember what their a was, but it was x minus 10.47 plus, I think it was 14.98. And this gave you the vertex of 10.47, 14.98. That's giving you that vertex, that peak. So on the curve, it was giving you that vertex form, remember? That peak at the top. And this is just the general form, the basic form that we always use. Which format is this in? Is this in the general or the vertex?
Oh, general.
General, right? Huh?
Oh.
You didn't have to write that part down, I'm sorry. I'm sorry, I was just trying to help you out. That was just connecting to prior knowledge. That was connecting to what we did before. If you have this part written down, go ahead and glue this in your journal. We have something else to put on the back, but go ahead and glue that in your journal. When you've got that glued in, go ahead and turn the page. I'm going to be on the back of page 30 for me. You might be right next to it. We're going to do a drawing together. We're going to do a drawing. I'm going to walk you through it. So I'm just on the back. Okay? All right. We're going to draw a parabola. So you're just going to draw a nice curve. Don't make it too big. Pick a point on there, close to the beginning, and that's going to be where you're going to have a little guy holding the ball. Okay? And he's going to throw it to his friend, who's going to try to catch it. There's some vocabulary we need to know to be able to get key information from here. Let's start with something simple. Where we actually want to put it where the ground is. Okay? It makes where the ground is because you're going to figure out how high the ball is off the ground, right? You're measuring the distance from the ground. Okay? So this is going to be our x-axis. Now I'm going to tell you, when do we want to start looking at the ball? Oh, there we go. Okay, so we're going to want to start looking at this as soon as we throw the ball, right? That's where we want to start counting. So that's where your y-axis is going to go. We're going to be measuring this in time. Now it could be frames. It could be in seconds. I'm going to highly, highly recommend that you do your video in slow-mo. It makes it much, much easier to tell. Now let me show you a video from last class. Now I want to go to here.
Wait, what did that say?
Time, frame, or seconds. How do I pause? Okay. Can you guys see? Let me see if I can make this. Try to turn down the brightness a lot. it's easy to see on the phone, but see how you can, the shadow's easy to see, but see how I could count where the bricks are? You want to make sure when you're taking the video, you can see where the ground is, because you have to be able to count from the bottom up. Does that make sense? And then, I should be able to see, no, that's a different one. There. For some reason, and I can easily pause it at any point and see, they both threw it at the same time to each other because they were being silly. And they're like, dang, that made it hard. And it made it really hard for them. Does that make sense though? Do you see how you could pause it and you could easily count? I'll pause. See how I can count how far up that one is? You guys following me? Okay. Now I highly recommend that you have a group of 2 to work together, because then you only have to make 2 equations and 2 graphs and analyze 2 things. But that you get another person from another group to help you just do the video. It is the P word for it. Vertex. Now in the calculator, it's also going to call it your maximum. If it was a smiley face instead of a maximum, what would we call that? What's the opposite of a max? Mm-hmm. Yes. This is the math stuff I'm supposed to teach you, but I wanted to do a little bit more fun and do a hands-on activity. Okay? If this is the y-axis, what's it called where it's crossing the y-axis? What's the y what? Intercept. When it touches the ground over here, thank you very much. Now I want you guys to think about this for a second. That y-intercept, that's where it's leaving their hand at. Does that make sense? That's where it's leaving their hand at. So that's the intercept is, they may not drop it, right? If they drop it is where it would hit the ground. If they catch it, they're going to stop it up here. Now, from here, from where they start to where it could hit the ground, this is where it makes sense to look at the graph and that time frame. That's called your domain. Mm-hmm. The range is this part. Okay, so the domain once it hits the ground, you don't want to look at that data. It's not in the ground now. And before it leaves his hand is not interesting. And then the range is what heights make sense. If you tell me it's 5,000 feet in the air, I got a little concern. Why? You didn't throw it by hand 5,000 feet in the air, and how did you measure that? So it makes sense from when it leaves his hand, either it touches the ground or it gets caught. Does that make sense? Yeah, because the parabola, the model is going to have it keep going down, but in real life, can that go down below the ground? In real life, can you go back in time? So it only makes sense from when it starts to when it's either caught or stops. Okay, and the range, it can't go, there's a limit to how high you can throw it, and it can't go negative. Okay, so we're only going to look at this little piece. Does everybody understand? Okay, let me stop the video.